Okay, welcome back. So now that we know that our space gas model comes in okay, we can start to, I guess, add more of the specific structural properties and attributes that we want to start to make this model be able to be solved, and so we can start to get some results out of it. So the first thing I'm going to do is add some boundary conditions or restraints. Now the way to do this is if we go back to our Geometry Gym Structure Analysis tab, and in Space Gas, under the elements, you can see a create or find node component. And what we're going to do is basically find the nodes where we want to place these restraints. So for this model, we want to place a restraint at the bottom of this concrete plinth and also at each backstay. And we've already got that geometry or got those points from basically decomposing these curves. So what we can do is we can get the start points of each of these, and drag these into the create or find node component. Now if I click on this component, now I can see these points. What this component does is looks up a point location, a Rhino 3D point location, and either finds a node within the structural model which has been created as we start to create those, create the beam elements and so forth, or if it can't find one within a given tolerance as provided, it will create that. In this instance, because we do have a beam at that along those locations, it would have found a node that already exists in the structural analysis model. So it would have found the node that exists at the end of this beam. So in order to add a restraint to these nodes, there's a restraint input. Now, if I go to the space gas attributes, I can start to look at, there is nodes here which allow me to add restraints and also supports. In this case, I'm just going to add a restraint, and I can wire that into the restraint input. And I can just use a Boolean toggle here to select which restraints I want to fix. So I'm just going to put this into each one of them, except for the rotation. I'll allow rotation. I'm going to make that true. What I'm going to do is allow rotation at the, oh no, that's fine. I'll make them all fixed. I'll put an element rotation, so it will be effectively. What I'm going to do is basically add each of the restraints as true, which basically means a fully fixed restraint occurs at both of these, at all of those locations. Right, so now that we've added our restraints, I'm going to go back. Currently in the model, the default is that a member will have I guess a fixed end releases. Now there's obviously some members here, well, a fair few members which are going to be pin connected, which means we're going to want to make sure that we specify those releases as pinned. So how you do that is by adding some beam attributes to the beams that you've created. So again, under the attributes tab, I can click beam attributes, and if I drag this in here, this is for the vertical bracings. And what I'm going to do is I've got a parameter input here, release A, and release B, and you can see that these are by default fixed. So there's two ways of me setting this. I can physically go again to the Space Gas Attributes panel and specify a beam release, or I can right click on this release and specify it within here. We do provide some checkboxes to allow this as well. What I'm going to do is just do it via the component, so I can get a bit more of a visualization. Again, I'll do a Boolean toggle, and I'm just going to release these in the XX and XY direction. We'll double check in Space Gas that these are the right directions when we bake again. Now, for these cable elements, I also want these elements to be axial only, or not to take compression. So in the beam elements here, there's a member type input. By default, this is set to normal, but I can change this to a tension only element. So that means that these cable elements will be tension only. And because I'm only inputting one beam attributes into here, these beam attributes will be applied to every element that we put into this component. Actually, I need to make sure that my releases are both wide up to release A and release B. And what I'm going to do is add some beam attributes to the purlin ones as well. So what I'll do is I'll just copy these attributes and wire those in. Now for the purlins, I want to make sure that I switch back my member type to a normal member, or else I'll just be, I won't be taking any tension in those members. And then because these beam attributes are similar to what I want to apply to the struts and backstay elements, I can simply wire these into these elements as well. So these are my backstay, so I can wire that in there. My rafter elements, I do not want any beam attributes because I want to keep those as fully fixed the whole way along. And my plinth element, I want that to be fully fixed. Okay, now let's bake that back to Space Gas and make sure that everything is looking as we want it. So I'm just going to override test 1 again. Open Space Gas again, and I'm just going to create a new, and I'm not going to save that job because we're just building up at the moment. Oop. And just going to import that again. Okay. And what I'm going to do is I'm just going to I'll turn to wireframe mode and make sure that my releases are on, just to make sure that I've got all the releases I want in here. Okay, so I've got bracing releases, I've got the releases for my purlins, also for these. So everything looks like it's came in pretty good. I'm just going to click on this member and double check. Yep. Okay, so everything looks pretty good. Okay, so what we're going to do now is look at adding some loading and seeing how we can start to analyze this and get some feedback. Okay, so from that from that model, I just wanted to check quickly if I added a quick self-weight load case, quick self-weight load case, just to make sure the model ran before I started to moving forward with developing my Grasshopper script. So I've just done a linear static analysis under self-weight, and it looks like it's came out okay. So I've got some about 9mm deflection at the tip of those cantilevering members. Okay, so now I'm going to start to develop this in a little bit more detail, so I don't have to manually add loads and that to